doing functions today, and although it looks like a lot of notes, it's going to go through really quickly. So first thing we're going to talk about is what is a relation? Is it a set of ordered pairs? And ordered pairs are just coordinates or points on a graph. Sorry, I have some people reminding me, sending me a remind message. Apparently, Kimberly, you're not the only one that has some crappy internet today, but that's okay because you guys can watch it later, so don't stress out. If it cuts out, it's okay. You can watch it later. It's not a big deal. All right, we can represent it 3 ways: by a table, a mapping, and a graph. The graph you're going to know how to do. The table you should know how to do, and then the mapping is the different one, but it's not hard at all. All right, so your domain is all of the X values in the relation, and the range is all of the Y values. And again, the domain and range is not very hard at all. So none of this is really hard. And again, it looks like it's a lot of work, but it's really not at all. Okay. So the first one says express the relation, and it gives you a set of ordered pairs. So that's the relation. As a table and a graph, then determine the domain and range. So somebody tell me, because you already know how to do this, how do we graph the coordinate -2, 4? So if we started the origin, how do we get to -2, 4?
Go left 2 up 4.
Left 2 up 4. So we got that one. If you want to put it in the table at the same time, our X is -2 and our Y is 4, and we're done with that point for those 2 things. Somebody else, how do we graph 2, 5? From the order
2, right, 5.
other way around. Right and left is always first, and then up and down is second. So try that one more time. So right always comes first, or right, left comes first, and then up or down.
Right, 2, 5.
Right, 2 up 5. And again, if you put it in your chart, 2, 5, or your table. The next one is -3, -2. Left 3, down 2. Don't mix them up. Left 3, down 2. And in your chart, -3, -2. 3, 3. Right 3 and up 3. In your table, 3, 3. Your next one is 4, 2. That's right 4, up 2. And in your table, 4, 2. And the last one is 5, -1. So I'm going to go over 5 and down 1. And then put it in my chart. All right, so the domain and the range. Remember, the domain are your X values. So I'm just going to put a little X here to remind you. And your range are your Y values. Okay, so all you're going to do is make a little curly bracket. And if you can't make a curly bracket, you can make a squiggly line. It's fine. I don't count off for that regardless. And you're going to put all of your X values in order from least to greatest. So we want to do least to greatest. So what's our least amount? What's our least amount? Say it one more time. I'm sorry.
-3.
-3. So we got that one. I'm going to put a little check mark so you guys can see we used it. What else? What's our next one?
-2.
What's your next one?
2.
2,
Perfect. What's your next one?
3,
And then we're just gonna keep going, 3, 4, 5, and then another curly bracket. See, my curly brackets are messed up sometimes too. So don't stress out about drawing curly versus not curly brackets. All right. So your range is the same thing, but you're gonna use the y coordinates. Same thing, but you're gonna use the y coordinates. What's your littlest y?
-2,
We'll use -2. What's your next one?
-1,
Somebody else, what's your next one?
2.
Keep going.
3.
And then
3.
4 and 5. Perfect. And that's all you do for domain and range. So list in order, least to greatest. Same thing on both of those. And that's your first page. So see, I told you your first page goes really, really quick. The rest of it is pretty much like that too. Everybody good? I'm going to flip my paper. All right. Same thing again, except for this time they give us a table. So tell me what the coordinates are. If this is your table, what's your first coordinate or your first point?
-5, 3.
And you just write it in parentheses, -5, 3. Everybody tends to miss this for some reason, and you guys know how to do it. You've been doing it for a little while now. Somebody else, what's your next one? So I got that one right there.
-2, 0,
And if you want to graph them while you're doing it, that's fine as well. -5, 3 is left 5, up 3. -2 is left 2. Don't go up or down, so it's on the axis. What's your next coordinate? Somebody else.
2, 1,
2, 1. So that's right 2, up 1. And we took care of that one. What's your next one?
3, -4,
So we're going to go right 3, down 4. And we took care of that one. And then the last one is 0, 2. That means don't go left or right, just go up 2. And there's your graph and your ordered pairs. Remember, domain and range. Domain is the X. Range is the Y. It goes least to greatest. So the table is the easiest way to look at it. The points are not too bad. You can check it out right there. All right, so domain, your X value, and remember we go least to greatest. What's your littlest X value? And again, you can look at your table.
-5.
What's your next one?
-2.
Keep going if you want to.
0, 2, then 3.
Good. So write it just like that. So curly bracket, your numbers least to greatest with commas in between. Somebody else do your range. That means your Y values. I am not doing curly brackets good today.
-4,
You can keep going.
0, 1, 2, 3.
Perfect. That's it. Any questions on graphing, writing coordinates, or domain and range? All right. So how do you tell if it's a function? So how do you tell if it's a function? That's all this means. How to tell it is a function. So the first way is to make a table, and you want to make sure there are no repeat x's. To tell if it's a function, you don't have to redo everything. I'm going to show you how on that mapping and the vertical line test, so on your graph. So if we look at just our x's, we're not looking at our y's, they don't matter. Do we have any x's that repeat?
Yes.
The 1. That means that this is not a function. Okay, this is not a function. So if it repeats, it is not a function. If it's like the one we just did in number 2, I'm gonna slide up. I'll put it back in a minute. Are there any x's repeated in number 2?
No.
This one is a function. Okay, so that one is a function because of no repeat x's. Okay. All right, so we really haven't looked at a mapping yet, but I'm going to tell you exactly what it is. I think you may have seen one before. You've probably just forgotten about it. So each x only has one arrow, and you'll see what that is in just a minute, coming from it. And I'm going to give you an example of a function and not a function. So if I do this, if you look, this is the x, this is the y's. Each x only has one arrow. This one only has one arrow. So this one is a function. But if I make the same circles, that's the same circles. And I do like this. If you look at 3, it has 2 arrows coming from it. It goes to 1 and it maps to 0. This one is not a function. If we made these coordinates, we would have 3, 1 and 3, 0. So in our table, we would have 2 x's that were the same. Okay, so we don't want 2 arrows. And then the last way you tell is a vertical line test. So if I draw a vertical line anywhere, and the best way I can show you this is to use this little sticky note. As I go through, this point only has one time it touches, and it's got to be a vertical line. That's why I'm going this way, right to left. If I keep going, that point is only the one touching the Post-it note. 1 point, 1 point, 1 point, 1 point. But watch what happens right here. What happens right here?
2 points are touching.
Yeah, so that vertical line went through 2 points. So this one is not a function. Okay, so as long as I can slide my sticky note over and only touch 1 point, it's good to go. When I touch 2 points, it's automatically not a function. And again, we're going to do a few examples, so we'll be okay. All right, so everybody got this? We're okay? Tell me if you need it back. Tell me if I go too fast. All right, those little boxes at the top are absolutely nothing, so we're going to go to right here. So you need to tell me if they're a function or not, okay? So I'm going to start with the mappings. Remember, mapping has to have one arrow from each x. Is this one a function or not?
Yes. Yes.
Yes.
My phone went off into that.
Oh, everybody good? All right. We're
Sorry
going to,
about that.
it's okay. We're going to look at this mapping. What happens at 3? Guys, what happens at 3?
There's 2 1s.
Yeah, well, not 2 1s, but what? 2 arrows at 3, right?
Right.
3 points to 5 and 3 points to -1. We can't have that, okay? It has to be coming from the x. So this is not a function, or it's no, because of this right here.
Sorry, I was looking at number 2.
That's okay, it's okay. All right, so we're gonna look at 2 and 5. We're gonna look at the tables. So look at number 2. We don't care about our y coordinates. Do we have repeat x's?
Yes.
So this one is not a function. All right. Look at 5. They just gave you a horizontal table. We don't care about y's. Do we have any repeat x's?
No.
No.
This one is a function. That's all you do. It's that quick. All right, so then the graphs are the last thing that we're going to do on this part. If I move my Post-it note over, am I touching more than one part of the graph at one time?
No.
So this one is a function. And I know this graph is really, really light, but it looks like this. If I put my Post-it note right here, or even right here, I'm touching 1, 2, 3, 4, 5, 6 times. So is this a function?
No.
This is a no because it goes through it more than once. All right. This last part, all it says is function notation. This is a fancy way of writing y equals. Okay, it's a fancy way of writing equals. So if we had y equals 2x plus 3, we could rewrite it as f of x equals 2x plus 3. So it's just a fancy way. That's it. There's absolutely nothing else to that. All right. We are not doing this top point. We're not doing any of that. We're going to go here. And then this just says that we're going to evaluate functions. And so this first one says f of 2. Okay, so remember, I just showed you f of x. What did that 2 take the place of? If I had it as f of x, what did it take the place of?
X.
So f of negative 2 means what is the y coordinate? Of the point at x equals negative 2. All right, so this graph is hard to read. We're going to do the best that we can with it. These go up by tens, so this is 10, and this one's 20. Everything else, this is negative 1, negative 2, 1, 2, 3. This is negative 10. Okay, so just wanted you to be able to see those coordinates. All right, so our x-axis is this one. That's the one we're looking at. This is our x-axis. So wherever that x-axis is negative 2 is right there. Does everybody see that point that's above that negative 2? What I want to know is what is the y coordinate. So what is the y coordinate for that negative 2? What is this point right here? Negative 2 what?
X.
Ooh. Remember when we were doing our coordinates and we would go over 2 and then up a certain number? So we went over negative 2. How far up did we go to get to this point?
10.
10. It matches up with 10 on the y-axis. So f of negative 2 is 10. This one says f of 0, so I'm going to go to 0, which is actually the y-axis. How far up do we go to get to this point?
10.
10.
But what about this point up here? What's special about it? Or what's different about it?
It's an open circle.
Yeah, an open circle where it's not filled in. An open circle is not really on the graph. This is a really bad example for you guys because you won't learn about open circles for a little while, okay? And it's not in this course, okay? So you talked about it with inequalities, graphing it on the number line. It's the same concept. That means it's not really equal to this, okay? All right, and then we're gonna go to 1. What is the point at 1?
0.
0. That's all you do. So that's how you, oh, sorry. That's how you evaluate on the graph. Hold on. All right. So what happens if they give you something like this? It's the same thing that we just talked about. We had f of x. What did the 2 take the place of?
X.
So that's what we're going to do in the function. So f of 2 means we take that function, 5 minus x, and we plug in 2 for the x. We substitute for the x. What is 5 minus 2?
3.
Perfect. All right. So this one says take the function and plug in x. So we're going to put that -3 in. So 9 plus 6 times -3. So plug it in. These are the most missed problems on the test, and they're some of the easiest ones, okay? So just be careful. We get 9, 6 times -3 is -18. And 9 minus 18 is -9. All right. Our last page is dealing with just that. That's what our whole last page is. Okay. So the only difference is you have 2 to plug in for one function. So this one says write your function, but put in 4. What is 2 times 4 plus 3?
11.
11. That's perfect. And there's a couple of these that we won't do, so we're almost done. So bear with me just a couple more minutes and we'll be done. This one says write the function, but we're going to plug in 0. So 2 times 0 plus 3. What's 2 times 0?
0.
Plus 3 is
3.
3. Perfect. All right, the next one just says use g of x. They'll have the same letter. They don't switch it up like that. So g of x just means use this function. So we're going to use 3x minus 7. And we're going to plug in -2. So 3 times -2 minus 7. 3 times -2 is -6. And what is -6 minus 7?
1.
Try again.
-1.
Try again.
-13.
-13, yep. Perfect. All right, we're going to hold off on B. And I'm going to move to number 3. This one says h of 5. So it says write your function and plug in your 5. So we get 11 minus 4 times 5. What is 4 times 5?
20.
So 11 minus 20. And somebody tell me what 11 minus 20 is.
9.
Just 9? Positive 9?
-9.
Perfect. Watch those signs, guys. Nothing wrong with that. You did it right. Just make sure you have a negative because your higher number is negative. We're going to keep moving. We're not going to do that B problem. And we're going to look at number 4. This one says, write your function, but plug in -2. Since there's 2 x's, we're going to plug it in twice. And I want to show you something on this function. This is one on the test that will throw you off. It's always one of my most missed questions, something like this. So we're going to do -2 squared minus 2 times -2. And yes, I do want you to put the parentheses, and here's why. If I decide that I want to be lazy and put it in my calculator, I'm going to put my parentheses And it's going to look like this. Look at this answer. If you don't put parentheses, look what happens. Does everybody see that? Use parentheses, and it's because of this square right here, and it's order of operations that your calculator does. So just make sure, again, that you are using those parentheses. So our answer, a negative times a negative makes a positive 4. Negative times a negative makes a positive 4, which gives us 8. All right. This one, if we look at this one, it says plug in 1 and then add 4. Okay. So this says do the function, but add 4. So do the function, add 4. Then remember, we're going to replace the x's. So what we really have is 1 squared minus 2 times 1 plus 4. 1 squared is 1. Negative 2 times 1 is negative 2. And then plus 4. 1 minus 2 is negative 1. Plus 4 is 3. All right, so number 5 is the big one. This is the big one. You'll have one like this on your test. And again, this is the most missed problem on the test, one like this. So this says, write your function, x squared plus 3x minus 4. And it says plug in negative 4. Remember to use parentheses. Negative 4 squared plus 3 times negative 4 minus 4. I about didn't get that negative in there. Make sure you guys get that negative. You can use your calculator. I don't mind. You're going to be at home. I can't tell what you're doing anyway. And then just plug it all in. When you hit enter, you get 0. We're going to do one more and then we're going to be done. And if you want to stay, I'm going to do the other 2 just for fun with you. I would probably do those with honors more than I would with you guys, okay? So we're going to look at the next one. We're going to write the function. And we're going to plug in. Okay. So we're going to have 2 squared plus 3 times 2 minus 4. 2 squared is 4. 3 times 2 is 6 minus 4. 4 plus 6 is 10 minus 4 is 6. All right. So you do have a little quiz today. I'm going to stop sharing for a minute so I can look at you. You do have a little quiz today, so you want to go ahead and take that. You guys are leaving out of here and not doing anything. Some of you need to make sure that you spend this time doing that quiz. Y'all are starting to get absences, and that is not good. Okay, do not get absences because you're not doing your work. That's crazy. So again, go do that quiz right now. Take your time, do that. It's really easy. If you don't have any more questions, you are free to go. I'm going to stop recording.